Hello and welcome to this second video on design patterns. In this video we are going to introduce creational patterns and we will study the factory method. In other videos of creational patterns we will also have a look at the abstract factory and singleton patterns. Creational design patterns will help you to make the process of creating objects more flexible. The idea is to keep the system more independent on how the objects are created, represented, and composed out of their different parts. These design patterns will help you to configure your system statically. For example, with the factory method, you create subclasses. A factory method is a method that creates an object, and then by means of subclasses you can override this factory method to create instead different subtypes of the return type of the factory method. And also dynamically, for example, the abstract factory is basically a class that is responsible for creating a family of objects, and then by choosing a different factory you will change the type of objects that are created. So the idea is to have a more flexible application with respect to the creation of objects. Right. To explain the creational patterns, we will use this example of a labyrinth. The idea is to have a class maze here, which is made of rooms. And then a room has a room number and then is made of 4 sides. In each side you can have a wall, you can have a door, or you may have another room. So you see here, this is an example of looks like a composite pattern, right? And then in every element you have a method to enter that is overridden in the different classes. This is how we would encode this design in Java. We have an enumeration with the direction, we have the abstract class map site, then we have a subclass room, a subclass wall, and a subclass door, and then we have the class maze, which basically has methods to add rooms and to get the room by the ID. Of course, this is an incomplete implementation. But now let's have a look at another class, which is maze game, and which has a method to create a maze. You see, it returns an object of type maze, which is explicitly created here. So I create a maze, I create 2 rooms, I create a new door, and then I add the rooms, and then for every room I set the 4 sides. For example, this one has a wall, then a door, and then 2 other walls, and so on, and finally we return the maze object. Well, you see that this is an example of a method that creates an object, but it's quite large, right? So there are 4 invocations to set size and so on. So probably a better strategy is to initialize the room already in the constructor of room, because now the room needs to be configured externally, but all these details can be hidden in the constructor. And also it's not very flexible. So what happens if I want to create another form of labyrinth, for example, with different types of rooms or different types of wall? Well, then this algorithm here is not valid because I'm explicitly calling the constructor. You see, I'm calling the constructor of room, so I cannot change by a different type of room very easily, because recall that constructors cannot be overridden. And also the strategy to design the maze here is already fixed. So in this video and further videos we will see how the use of creational design patterns will help us to make this code here more flexible. In particular, we will use these three different design patterns. So we will use the factory method so that we will create objects using functions instead of constructors. Why is this important? Why does this make the design more flexible? Well, because methods, functions, can be overridden, and then you can change the type of what you are creating, because recall, when you override the method, you can have a covariant return type. So you can return the same type or a subtype of the method you are overriding. We will also use the abstract factory. The abstract factory, the idea is to have a class with a lot of methods to create the different objects you are interested in. And then by subclassification, you can change what is created in all these methods. And therefore, by passing here as a parameter different factories, different abstract factories, then we will be able to change what is created here, the type. And then we will also use the singleton to ensure that there is a unique labyrinth object in the game, and that this labyrinth object is can be accessed at any point in the program. Right, let's start with the factory method. In this design pattern and in the following ones, I'm going to use the standard structure of description of a design pattern. So first of all, what is the purpose? Well, the purpose is to define an interface to create an object. So the idea is that then subclasses can decide which class to instantiate. By doing this, we are delegating the creation of objects to the subclasses, but defining an interface that is followed by all the subclasses. Sometimes this pattern is also known as virtual constructor. Now let's see an example that motivates the use of factory method. This is a concrete situation, a concrete problem that benefits from using the factory method. And the example is based on application framework. What is an application framework? Well, an application framework is a set of classes that you can reuse in your application, but it's not a library, right? Because in a library you use the classes as they are. In an application framework, the idea is that some of the classes are abstract or uncontained contain methods that need to be overridden. So the application framework, in an application framework, you need to subclassify from existing classes and override some of their methods. So imagine an application framework that should be able to present different types of documents. Actually, this example is taken from the Microsoft Foundation classes from MFC that had exactly this design here. In that framework, you have two types of abstraction. You have the document, which is the document that the application is going to implement, and then an application who knows when to create the document, but doesn't know the type, because the idea is that the programmer should define subtypes of document, right? And then, of course, needs to configure the application with the type of document that the application should handle. So what's the solution to this problem? The problem is you need to define, when you define an application, you need to define a type of document, right? And then the application should somehow be configured with the type of document to create. So the idea is to use subclassing, right? So encapsulate the knowledge about the document subclasses and creating and moving such knowledge to the framework. We are going to see this with a concrete design. So the idea is that the application framework will provide you with these two classes. So you have an abstract class document and an abstract class application. And then this abstract class will have a lot of functionality to create new documents, to open the document, to persist to do a lot of functionality. But of course, to create the document, how do I create the document? Well, we don't know, because the programmer needs to create a subclass of document, right? And document has method to open, to close, etc. So the idea is that instead of So we don't know how to create a particular subtype of document here, but what we do is we just create an abstract method, which is create document. This create document will return a document, right? And the idea is that you should classify here my application and override create document. When you override create document, then you can put here code to create the actual type of document here. You return my document, right? And then that's fine, because the rest of the methods here in application, whenever they need to obtain a document, they call create document. And that's fine. They will execute this code here, right? This is a template method, right? Because I have a template here that relies on methods that will be overridden in subclasses. This is another design pattern. But the idea is that this create document here is a factory method. It's a method that needs to be overridden here, and the code that is overriding will create a new type of document. Right, so when are you going to use the factory method? Well, when, as in the example, a class cannot predict what is the class of object it needs to create, right? The application class cannot predict which subclass of document that class needs to create, right? Because the subclass of document will be decided by the programmer. Or when you want the subclasses to decide which objects to create. You do this via subclassing and overriding the factory method. And in general, when you delegate the responsibility to subclasses about which objects to create. Right, so each design pattern has a name, but then it also provides a general template with the structure of the solution. And the names of the different classes and methods are also important. These are the roles of the patterns, and they provide you a vocabulary so that you can communicate with your colleague engineers to discuss about the solution. So for example, here we have a creator class, which is this abstract class that has the factory method, right? This is the factory method is this abstract method that creates an object and that needs to be overridden by concrete creators, right? So I have here one concrete creator, but of course I may have many subclasses of creator that would be different concrete creators. And then we have the products. We have the abstract class product, and then we have the concrete product. Each concrete creator is paired with a concrete product, which is the product, is the object that is created in this factory method. So you see here we return this concrete product here, and the idea here is that many methods of the creator class may rely on this factory method to create a product P, but of course different concrete creators will instead create concrete products and not really the product class, because this is an abstract class. Well, all design patterns, they have a section about the consequences. So what is really happening if you use the pattern, what are the advantages, what are the disadvantages. So here, if you think about this, what will happen is that you have a connection of two types of hierarchies, the hierarchies of the concrete creators and the hierarchy of the products and the concrete products. So here we have a concrete example where we have a drawing application that has to handle figures. For example, you have lines, you have text, but you may have also circles, rectangles, and whatever. And then to manipulate those figures, we have manipulators, so handling things, user interaction like clicks, drag and drops, up clicks, and these kind of things. And the idea is that each figure has its own manipulator, right? So this is an application of the factory method, where this is the creator and these are two concrete creator classes, right? So that's the factory method, create manipulator, that is overridden in line figure and in text figure. And here we have a product, which is the manipulator, and two concrete products, which is the text manipulator and the line manipulator. In this way, a line figure will create a line manipulator and a text figure we create a text manipulator. So you see that we have two parallel hierarchies, one with the products here and the other with the creators here. Right, let's see how to improve the running example with the factory method. So recall that we have here a method to create the maze, where we were calling here directly the constructor to create a room, to create a door, to create a wall, etc. Now, what we want to do is we want to encapsulate those calls to constructor to factory methods, right? So instead of calling here directly the constructor, we call factory methods that are defined here. So all these are factory methods to create a maze, create a wall, create a room, and to create doors. And so this class here, according to the design pattern, would also be a creator, and this would be concrete products. So you see here that now the advantage is that if I want to create a different type of maze with different types of rooms, for example, enchanted rooms or enchanted doors or bombed walls, bombed rooms, or whatever, what I need to do is I need to create a subclass of maze game that overrides these methods here to create different types of rooms, different type of doors, different type of walls, etc. But then this method will work just the same, because this method contains invocation to these methods that will be overridden. So that's a nice strategy, because you see that the creation algorithm is fixed, but then it can be modified in the subclasses of maze game. This method here is using a design pattern that is called template method, where an algorithm like this one here that is creating labyrinths has points of variation as given by these methods here, and these points of variation, these methods can be overridden in subclasses. And then at runtime, the virtual machine will select the version of these methods corresponding to the runtime class of the object that is executing this code here. Of course, regarding the implementation, there may be different options to implement the same idea. So my question here is, how could we implement this pattern in a different way using lambda expressions? I will use this same example to illustrate the use of this lambda expression. But it's better if you stop the video for a while and think, how could you implement this using lambda expressions? Well, this is one possibility. So we only need to configure the application with the type of object to create. And what we could do is we could use a method to configure this application by passing as parameter a supplier. Remember that a supplier receives is a functional interface that has a method, get, that returns an object. So the idea here is that we parameterize application with a supplier that provides a subclass of document, and in create document, what we just do is we just call the method get to the supplier that we have stored, right? So that's a different way to implement the same idea, where we do not need to create a subclass of application, but instead the class application has a method, set product supplier, that we need to implement with a lambda expression here, for example. So we create the application, and then we set the supplier here by having, for example, this reference to the constructor of my document, where my document is a subclass of document. Well, you see that here this has the drawback that we rely on a constructor that has 0 parameters, where the canonical implementation of the factory method can the factory methods can have and can invoke constructor with any number of parameters. Alright, so this finishes the introduction to the factoring method. I recommend you to try out the exercises and to have a look at the bibliography. In particular, I would recommend you to have a look at the original book of the design patterns by the Gang of Four.